We will now determine the basis for the kernel of some matrix A. Consider the following matrix, which is a 4 times 5 matrix. And suppose that we already did some preparations and that we know that the reduced row echelon form of A is the following. Then, first of all, if we solve solutions, AX is 0, then we know that this solution won't change through Gauss-Jordan elimination steps. So the kernel of A is the same as the kernel of the reduced row echelon form. So now look at this reduced form and we see that we have two pivots. So we have two leading ones, which means that actually we have 3 columns that correspond to 3 variables. So we have 3 free variables. If we solve for the kernel. So let's say that x belongs to the kernel of A if and only if x equals, well, we now write x down in coordinates, x1, x2, x3, x4, x5, and now we choose x2 equal to r, x4 equal to s, and x5 equal to t, which are the 3 free variables, x2, x4, and x5. So we write r, s, and t. Then we may express x1 as minus 2r minus 3s plus 4 times t, which we can clearly see by and on this line. And we may proceed. So x3 is 4 times s minus 5 times t. So actually, given r, s, and t, we may express a kernel element by r times minus 2, 1, 0, 0, 0, plus s times minus 3, 0, 4, 1, 0, plus t times 4, 0, minus 5, 0, 1. So for given constants r, s, and t, any of such linear combinations that we make belong to the kernel. So we can span the kernel of A by the 3 vectors minus 2, 1, 0, 0, 0, minus 3, 0, 4, 1, 0, and finally 4, 0, minus 5, 0, 1. So suppose we take those 3 vectors in a basis, then we actually showed that the linear subspace, which is a kernel is a linear subspace, so it is spanned by the 3 vectors that we found. And also these vectors are automatically independent, linearly independent. Well, why is that? Well, for each free variable we create a 1 where the other vectors have zeros. So none of these vectors, so for instance the vector corresponding to r, to the second free variable, has 1 on the second coordinate, whereas the others have only zeros. Similarly for x4, the free variable, we have a 1 on the 4th coordinate, and the 5th free variable has a 1 on the 5th coordinate, which cannot be replaced by the other vectors. So actually we've shown that we have a span, and the span of these 3 vectors equals the kernel, And also we've seen that these three vectors are linearly independent, which means that we've constructed a basis here.